Good afternoon. My name is Bruno Garcia. My class is 1406, Section 2. Well, first of all, this is my last video that I'm going to be doing for Professor Trent. Second of all, I want to thank Professor Trent for teaching me lots of things that I didn't know. And as the semester kept on going, it was hard, but I had to keep up with his lectures, and now I feel really comfortable and ready for my final exam. So, going back to the main point, I'm doing this video on translation, and I'm explaining the 3 steps of translation, which is initiation, elongation, and termination. First of all, here are the processes, you can see them. First of all, transcription is the process by which a DNA sequence gene is copied into a complementary sequence of RNA by an RNA polymerase, obviously. First of all, there are some factors that I want to include in this presentation. Well, just like the free nucleotides that exist in the cell as nucleoside triphosphates, which are the NTPs. I don't think we can see them here. Well, anyways, the RNA polymerase covalently binds the NTPs together in a reaction that involves the release of the 2 additional phosphates. I want to start with transcription, which goes in the 5 to 3 direction. Here you can see the 5 to the 3 direction. You can see over here how it ends in the 5 to 3. And the process of transcription can be divided into the 3 main steps, which are initiation, elongation, and termination. These steps are essential for the process to happen so we can transfer the sequences into the RNA. In its initiation, the RNA polymerase binds to the promoter and causes the unwinding and separating of the DNA strands. We can see here how they're both separating, and both DNA strands are going by another direction. We can see how here they're unwinding and separating. Elongation occurs as the RNA polymerase moves along the coding sequence, synthesizing RNA in a 5 to 3 direction. Just like I said before, oh my god, I made a mistake. It's over here. The elongation is right here. When RNA polymerase reaches the terminator, both enzyme and the nascent RNA strand detach and the DNA rewinds. You can see here they already detached and they're rewinding again. I don't know if you can see it right here. Many RNA polymerase enzymes can transcribe a DNA sequence sequentially, producing a large number of transcripts. In eukaryotes, post-transcriptional modification of the RNA sequence is necessary to form mature mRNA. Transcriptional activity is regulated by 2 groups of proteins that mediate the binding of the RNA polymerase to promoter. There are some factors, just like the transcription factors, which forms a complex with the RNA polymerase, and also the promoter of the RNA polymerase cannot initiate transcription without these factors, and hence their levels they tend to regulate the gene expression. Since gene expression it's really close, it's just based off the transcriptional process. The regulatory proteins bind to the DNA sequences on the outside of the promoter, and they interact with the transcription factors. The activator proteins bind to the enhancer sites. They're somewhere here. The role of the activator proteins is to increase the rate of the transcription, which means it increases the rate so it can go faster and quicker to keep transcribing and keep the process going. Next is the repressor proteins, which bind to the silencer sequences and decrease the rate of transcription. These proteins are really essential for this process of transcription in order to keep like the transcription process ongoing but without stopping, because you don't want that transcription process to stop, because you don't want to stop building DNA sequences and sending the DNA sequence to the RNA polymerase. Well, this is all for this video. I hope you got some information, and I chose this topic because it's gonna be one of the main ones in the test. And that's it. Thank you, Professor Trent.